Let's talk about how networks are actually shaped. Because there are two completely different questions people ask about any network, and almost everyone mashes them together into one confusing mess. Here's the rule we're going to live by. If I can't explain something to you without hiding behind technical terms, then I don't really understand it yet. So let's earn it. Start with one picture. Not a network diagram, an actual map. Towns and the roads between them. Now, look at that map and ask two questions. Question 1. How big is the delivery area? Is it your desk? Your building? Your city? The whole planet? That question, that's a network type. Question 2. How are the roads laid out? Is there one main street? A loop? Does everything run through a single roundabout? That question, that's a topology. And here's the thing. Those two questions are completely independent. A tiny office and a giant enterprise can use the exact same road layout. Keep them separate in your head, and this whole topic stops being confusing. So, question 1 first. How big is the delivery area? Read these as circles, growing outward from you. The smallest one, a personal area network. Your body-sized bubble. Your phone talking to your earbuds and your watch. A few meters, usually Bluetooth. That's a PAN. Next circle out, a local area network, a LAN. One building, one floor, one house. Your home Wi-Fi and everything on it. This is the one you'll live in professionally. A single location, you own the gear, and it's fast because the distances are short. And a WAN? That's just a LAN whose last hop is wireless. Same network, no cable. Next circle, a campus area network. Several nearby buildings that you own. A university, a hospital, a corporate campus. Really, it's just a bunch of LANs, stitched together with your own cable in the ground. Next circle, a metropolitan area network. City scale. A city government wiring its libraries and its offices together. And notice, you've stopped owning all the cable now. You're leasing. And the last circle, a wide area network. Any distance. No ceiling. 2 branch offices in different states. The internet is the biggest wide area network there is. But here's what I want you to catch. The thing that defines a wide area network isn't the size. It's that you don't own the road anymore. Somebody else carries your traffic, and you pay them for it. And that's the real pattern underneath all 5. As the circle grows, you own less and you lease more. And it gets slower. The size is just the visible part of that. Okay, question 2. How are the roads laid out? There are 5 layouts. And for each one, I want you tracking the same 2 questions. What happens when one thing breaks? And what happens when everyone talks at once? Layout 1. The bus. One cable and everybody taps into it. It's cheap and it's dead simple. One hallway with doors off it. But everybody shares that one hallway, so traffic collides. And if you cut the hallway, the whole network dies. This one's history now. You'll meet it on an exam, not in a building. Layout 2. The ring. Each device connects to exactly 2 neighbors, and data travels around the loop, passing device to device. No collisions, because there's orderly turn-taking. But one break, and it's severed. Which is exactly why real rings get built as double rings, so traffic can reverse and go around the other way. Layout 3. The star. Everything plugs into one central device, a switch. And this is good. One cable fails, and it takes down only that one device. Troubleshooting is trivial because you know exactly where to look. The cost? The hub is a single point of failure. Kill the switch, and you lose everything. And this is what basically every real network you touch actually is. Every office, every home. Layout 4. The mesh. Everyone connects to everyone. And the redundancy here is unbeatable. Traffic just routes around a break, and there's no single point of failure anywhere. The catch is cost. The connections explode as you add devices, so it's impractical for endpoints. But where you do find it? Where reliability is worth the money. The backbone of the internet is a partial mesh. Layout 5. The tree. Stars, plugged into other stars, in tiers. A switch on each floor, feeding a core switch for the building. This is real enterprise architecture. It scales cleanly, and you can segment it by tier. The trade-off. A failure high up in the tree takes down everything underneath it. Now, here's the gap check. The part that tells you whether this really clicked. Your office network is wired as a star, but Ethernet was designed as a bus. So, which is it? And if you can't answer that, we're not done yet. So let me close the gap. The answer is both. And that is not a contradiction, because there are two topologies, not one. Physical topology is how the cables actually run. Logical topology is how the data actually flows, and they do not have to match. Watch. Plug 4 computers into an old hub. Physically, that's a star. 4 cables radiating out from a center. But a hub is dumb. It shouts every frame out of every port. So logically, every device still hears everything, and every device still collides. Physically a star. Logically, a bus. Now swap that hub for a switch. And here's the key. The cables don't move. Not 1 inch. But the switch is smart enough to send each frame only where it belongs. And now it's physically a star. And logically a star. That's the whole lesson, in one sentence. The cable layout tells you what breaks. The data flow tells you how it performs. Same picture, 2 different questions. And it is exactly why we upgraded from a hub to a switch fixed an entire network, without anyone touching a single wire. If you made it to the end and you liked this content, don't forget to like, comment, and subscribe.